When you're asked to identify the zeros in the asymptotes and then graph, sometimes you also have to check for horizontal asymptotes. So we're going to have three things we're looking for here. So we're going to have zeros, and that's when 3x squared minus 12 equals 0. We're going to have the vertical asymptote, and that's when the denominator, or x squared minus 9 equals 0. And then we're also going to look for the horizontal asymptote. And the horizontal asymptote depends on the degrees of the numerator and the denominator. Alrighty? So your degrees on top and your degrees on the bottom. Alright? So here we have a second degree. We have 3x squared on top, and then we have a plain x squared on the bottom. You're only going to be looking at your leading coefficient and the degree of your first term. Alright? I see that my degrees are the same. When the degrees are the same, your horizontal asymptote is the ratio of the leading coefficients, or 3 over 1. So I have a horizontal asymptote at the value y equals 3. That's the hardest part of this problem, because the rest of it we've already done. To find my zeros for my numerator up here, I factor 3x squared minus 12. Well, 3 can come out of both terms, so it's 3x squared minus 4, and I see that this is a difference of squares, so it's actually 3x plus 2, x minus 2. So that I have zeros, x plus 2 equals 0, or x minus 2 equals 0, minus 2 minus 2, that's a 2. So x can equal negative 2, or x can equal positive 2, and that will give me my zeros. And then my vertical asymptote is when my denominator equals 0. And this is also a difference of squares. So I have x plus 3 and x minus 3, which means I will have two vertical asymptotes. I'll have one at x equals positive 3 and one at x equals negative 3. Sorry. And this all doesn't make any sense until we graph it. So let's go. I'm going to graph this. I'm going to make a little teeny tiny graph. So here is my axis. I have my zeros in green at negative 2. There's negative 2. And at positive 2. Positive 2. And then I have vertical asymptotes in red, and that's at negative 3 and positive 3. And then I have a horizontal asymptote in blue at y equals 3. So I go over 1, 2, 3. It's going to be right here. That gives me my boundaries for the graph, but it doesn't make a whole lot of sense until I zoom out and I think, if I have zeros here and a roof right here, my graph is probably, a piece of my graph is going to go like this. But then there's also two other pieces up here. I'm going to switch you to Desmos so you can see what it looks like. There we go, right here. Here's our original graph. I factored the 3 out. Let me change it for you so you see it's exactly the same. This numerator right here is 3x squared minus 12. Let's make that so you trust me. That's going to be 3x squared 1 over minus 12. There we go. And as we can see, we have our zeros at the point -2, 0. There's 1. The other one is at the point 2, 0, just like we calculated originally by hand. And then we have vertical asymptotes where our denominator would be 0, and that's at x equals -3. I'm going to make that one a different color. Let's make that one green. Green. There we go. And the other one is at x equals -3. Make you green. Green. Alright. And then the final piece, the new piece we did this time, was the horizontal asymptote, which we determined was at the line y equals 3. And you're not going to be green, you're going to be, what color? We'll make that one purple. There we go. And let's put this in projector mode so you see it better. There. All of our lines are a little thicker. This is my function right here. And there. These are my vertical asymptotes, my green lines right here. This is my horizontal asymptote, which is the ratio of the leading coefficients. This 3 divided by the invisible 1 in front of the x squared. And then finally, where it's crossing the x-axis, my roots, my solutions, my zeros. They are always where we cross the x-axis.